All right, quiz 2 solutions for Math 1 12. We're dealing with exponential functions here, so the specific exponential function f of x equals negative 16 times 2 to the x power. And the first thing we're asked to do is determine f of negative 2. So what you need to know first off is to determine f of negative 2, all you got to do is kind of copy this as like a blueprint, but change all of the x's into whatever in the parentheses, negative 2 in this case. So f of negative 2 would be negative 16 times 2, not raised up to the x power, but instead to the negative 2 power. And then to evaluate this, well, I guess you need to know what 2 to the negative 2 power is. But 2 to the negative 2 power is 1 over 2 squared, because negative exponents, informally speaking, mean take the reciprocal of that base. And since 2 squared is 4, this is just negative 16 times a quarter, which is negative 16 fourths, or negative 4. Next, we're asked to solve f of x equals negative 2. It looks really similar to what we're asked to do up here, except now it's not the input that is told to us to be negative 2. It's the output that's negative 2. So instead of changing all the inputs, the x's into negative 2's, I'll take the output, which is negative 16 times 2 to the x power, and set that equal to negative 2. And solving this equation, well, it's a little bit challenging, but maybe it would help if I could get the 2 to the x all by itself. To do that, I could divide both sides of the equation by negative 16. So 2 to the x equals negative 2 divided by negative 16. Well, the negatives cancel each other out, and 2/16 is the same as 1/8. So now I just got to ask myself the question, what power do I have to raise 2 up to make it equal to 1/8? Well, 2 to the third power equals 8, because 2 times 2 times 2 is 8. But I don't want 8, I want 1/8. So I guess I need my exponent to be negative. I need x to be equal to negative 3. 2 to the negative third power is the 1/8. And if you can just see that, great. If it's easier, the trick that we learned is to rewrite 1/8 as 2 raised up to some power to equate the different bases. And to write 1/8 as 2 to some power, well, you need the power to be negative 3. So either way is good, will get you to this answer. The second question says that suppose f is an exponential function. Maybe I should have changed the letter. Maybe instead of using f twice, we should call this g. So when you see this quiz, it'll say suppose that g is an exponential function and that g of 3 equals 12 and g of 1 equals 3. And what we're supposed to do is find the equation of g of x. Well, I know that since g of x is exponential, it can be written in the form a times b to the x power. And this first equation tells me that when x equals 3, y equals 12. So 12 is equal to a times b to the third power from this statement. And from this statement, I know that 3 is equal to a times b to the first power. And we learned this trick where you can divide the two equations if you put the one with the larger exponent on b up on top. So 12 divided by 3 is equal to ab cubed over ab to the first power. The algebra will work out a little bit nicer for you. 12 thirds is just equal to 4. Over here, the a's cancel out, so I'm left with b cubed over b to the first power. And an exponent rule allows me to rewrite this as b raised up to the 3 minus 1 power. In other words, the second power. So 4 is b squared, and that tells me that b equals 2, technically plus or minus 2, but b is assumed to be a positive number. And once I know that b is equal to 2, I can solve for a by plugging it in wherever I want to plug it in. This one might be easier. I get 3 is equal to a times, and then instead of writing b, I'll write 2 raised up to the 1 power. So 3 is equal to 2a. So dividing both sides by 2, I get that a is equal to 3/2. And now that I have a and then I have b, I guess I have the equation for g of x. G of x would just be equal to a times b to the x power. So 3/2 times 2 raised up to the x power. Then on the second page, we're asked some questions about graphs of exponential functions. So you have the graphs of 4 different exponential functions given here, f, g, h, and j. And what we're going to be asked about is the values of a and b in the equations of each of those 4 functions. So the first question just asks which graph has the greatest value of a. And I guess what you need to know is the value of a is just the y-intercept. So all I got to do is look up here and figure out where the y-intercept is the greatest. It looks like right here, and this corresponds with this graph g. So my explanation would be something like this. Since a is just the y-intercept, g has the greatest value of a. Then it asks which graphs, if any, have values of b that are greater than 1. And what you need to know is the value of b tells you how much we're going to multiply the height by each time we take one step to the right. So when the value of b is greater than 1, we're getting further and further away from the x-axis when we go to the right. Note that g, h, and j all get closer and closer to the x-axis when we go to the right, so each of their values of b must be less than 1, but f gets further and further away from this axis, so f must have a value of b that is greater than 1. Note that I wouldn't want to say it goes up when I go to the right, because technically h and j go up when you go to the right as well. So that's why we talk about its position relative to the x-axis here. What about C? Which two graphs have the same value of A? Well, again, A is just the y-intercept, so I just look up here and figure out which two graphs have the same y-intercept. It looks like H and J do. So my broken English kind of short explanation for y is just H and J have the same because they have the same y-intercept. And then finally, is the value of B in H greater than, less than, or the same of the value of B for J? So I'm supposed to compare H and J and specifically their values of B. I think this is the hardest question on these graphs. First off, the reason I can compare their values of B is because they have the same value of A. So it'd be really hard for me to compare together the values of B between G and H, for example, but between H and J I can do it. They have the same height right here, but when I take a step to the right, wherever that ends up being, H gets closer to the x-axis than J does. So what that means is I'm multiplying this by a fraction that's closer to 0 than I am this. In both cases, B is a number that's less than 1, but in this case, B is closer to 0 than this one is. So what that means is the value of B for H is smaller than the value of B for J. Of course, your justifications don't have to match my justifications, but here's kind of the idea of what I'm looking for each of these 4 problems. And that ends the quiz.